This video is binomial distribution part 6. We're starting with example 5, Google searches. According to a Nielsen report, 65% of internet searches in May 2010 used Google. In a sample of 25 searches, if a sample of 25 searches are randomly selected, find the probability that, and then we have 5 different probabilities we want you to find. So pause the video, work through these. You can use your calculator, the binomial PDF or CDF functions, write out which function you're using and the numbers that you are entering in your calculator, and then unpause the video when you're finished to check your answers. Okay, so for each of these, let's look at the first one. Probability of exactly 20 would be a PDF, binomial PDF. Trials is 25, probability is 0.65, and 20 would be your X. We get 0.0506. For 15 or fewer, that includes 15, we want the probability of 0 plus 1 plus 2 plus 3 all the way up to 15. So we would use the CDF function 25.65 15 because we want it to stop adding at probability of 15. We get 0.3697. More than 22, you have to use the complement. More than 22 is 23, 24, and 25. We need to find the probability of 0 up to 22, the complement, and subtract that from 1. So 1 minus binomial CDF 25.65, 22, and we get 0.0021. Fewer than 12 means less than 12. So less than 12 would be 0 up to 11. It would not include 12. It would stop at 11. So binomial CDF 25.65, 11, and we get 0.0255. 17 or more include 17. That's 17, 18, 19 up through 25. So we have to find the complement of 17 or more. So if we want 17 or more, our complement stops at 16. So binomial CDF 25.65, 16 is the complement. We subtract that answer from 1 and we get 0.4668. Okay, so here we're going to talk about mean and standard deviation. So if X is the binomial random variable within trials and a success probability of P, the mean of the random variable is using this notation, mu subscript X equals N times P. Now this is also the same thing as expected value. So if they ask us to find the expected value for a binomial random variable, then you can find the mean of the random variable and use this formula, N times P. You can also make the table in the calculator like we've done, and then use var stats L1, L2 like we did by hand for a regular probability distribution. This is just a shortcut for the mean for binomial distributions. It's just a little quicker. Now, don't worry about variance because we're not going to be finding that, but you will need to find the standard deviation. The standard deviation, the notation is sigma subscript X, and that equals the square root of NPQ. Now, this is a reminder that Q is the complement of P, so that's 1 minus P. Alright, so let's look at some questions. The statistical abstract of the United States reported that 67% of the students who graduated from high school in 2007 enrolled in college. 30 high school graduates are sampled. Find the probability that exactly 18 of them enroll. So if we want exactly, keyword exactly, we're going to use binomial PDF. The number of trials is the number that were sampled, which is 30. The probability of a success is 0.67, and we want 18 for the x. So if you plug that into your calculator, and we get 0.1068. If we want the probability of more than 15 would be the probability of 16 plus the probability of 17 plus the probability of 18 up to the probability of 30. So we need to find the complement of that. The complement that starts at 16, for the probability that starts at 16 and goes to 30, the complement stops at, it goes from 0 up to 15. So we're going to do 1 minus binom CDF 30.67. If we want 16 and up, we need to find the complement which stops at 15. 15 would be our x. So 1 minus that, 1 minus second vars binom CDF, 30 trials, 0.67 is p, 15 is x. Don't forget to do 1 minus. We get 0.9601. Okay, fewer, what about fewer than 20? Fewer than 20 doesn't include 20. It's the probability of 0 plus the probability of 1 plus the probability of 2 all the way up to the probability of 19, because fewer than 20 doesn't include 20. It's 0 to 19. So that would be binom CDF 30.67 20. Oops, I'm sorry. I said it didn't include 20. I just wrote 20. We want to write 19 instead. And we get 0.39998, which rounds to 0.40000 if you round to 4 decimal places. How many of these students would you expect to enroll in college? Expect, we needed an expected value. Expected value is the same as the mean of the random variable. And recall the mean of the random variable is n times p. So n is 30 times p. P is 0.67. And if we multiply those two together, 30 times 0.67, we get 20.1. Okay, now it doesn't ask for this, but let's say, what if they asked for the standard, oops, let me erase that real quick. The standard deviation of the random variable. So sigma x is equal to the square root of NPQ. Oops. N is 30. P is 0.67. We need to find Q. Q is 1 minus P. So that's 1 minus 0.67, which would be 0.33. So times 0.33. Now, square root. Square root. How do we put that in the calculator? Let me show you. So square root is You see the x squared button right here, right there? Square root is above it, so it's a secondary function. So we hit second x squared will give us the square root sign, and then you'll type in 30 times 0.67 times 0.33, and we get 2.575. So 2 sorry, I lost my, there it is, there we go, 2.575. That's how you find the standard deviation of the random variable. Alright, one more example. 65% of people pass their driver's exam on the first try. A group of 50 individuals who have taken their driver's exam is randomly selected. Find the probability that 30 to 35 of them passed on their first try. First, let's label a couple things. P is the probability that they pass the exam. That's the same as the 65%, so 0.65 is P. And let's see what else. N is the sample size, the number of trials, which is 50. Okay, so we want 30 to 35. So basically what we want is the probability of 30 plus the probability of 31 plus the probability of 32 plus the probability of 33 plus the probability of 34 plus the probability of 35. Okay. If you think of what comes before this, before the probability of 30, we got probability of 29, probability of 28, all the way down to probability of 0. So, what we could do is we could find the probability up from 0 up to 35 by doing binomial CDF 50.6535, and then we can subtract from 0 to 29, and then that will leave 30 to 35. So 29 would be binomial CDF 50.6529. We would do 29 because we still want to include 30 up through 35, and then we would subtract those two. And you can type it in just like this. You can type it in binomial CDF 50.6535 minus binomial CDF 50.6529. And it looks like your answer would be 0.6262. And that is all for binomial distribution. Let me know if you have questions.